Another type of vector problem you can do is vector problems involving forces, okay? We can apply forces in different directions. The units used for forces are often in either pounds or newtons, okay? So, common sense says if two people are pulling in the same direction and one person's applying 50 pounds of force and the other person applies 100 pounds of force, you'd have a total of 150 pounds of force, just those two forces added together. But what happens if those forces aren't at exactly the same angle? Okay, so let's imagine we've got some people here. Maybe there's a rock, and some people have tied ropes to this rock. Okay, and I'm going to use newtons here. Newtons is another unit for force. Some of you might have used that before. This person is basically pulling with a rope 200 newtons of force at 70 degrees. Okay, this person here is applying 150 newtons of force at a 30-degree angle. And I want to figure out, if you add those two forces together, what's the overall force going to be? And they're not both being applied in the same direction, so it's not just going to be the sum of those two forces. And number two, what's the final direction that we would expect this rock to move in if it was going to move, okay, if two people were doing this? Same kind of thing as before. You want to show this with the two vectors being added head to tail, okay? So I'm going to take I've got a 150 Newton force at a 30-degree angle, okay? And then I've got my 200 Newton force at 70 degrees. Actually, I should probably make that a little bit steeper. 200 newtons at 70 degrees, okay? And the resultant force is going to be the force that goes from the tail of one to the head of the other, okay? That's what I'm looking for. All right, so like the previous problem, I'd like to try to find this angle measure here, and we're trying to find this side length here is where we're going, okay? So we've got two sides of a triangle. We'd like the angle measure in between it, then we can take the law of cosines to find the missing value. Okay, so I always draw a little horizontal line for starters, okay? If this is a 30-degree angle, we've got alternate interior angles here, that's also going to be a 30-degree angle, all right? If this is a 70-degree angle, you can use that horizontal and, ooh, I didn't do it in the same direction. Oh my, let's see. Okay, let's change my picture just a little bit here. Sorry. This person's doing 70 degrees in this direction at a magnitude of 200. So yeah, it's leaning like that. So this is a 70-degree angle. Oh, you've got a straight angle here, so that's got to be the supplement. That's 110. So so a better drawing of this, the resultant vector is going to go through like this. Now, we still have the same thing. We know we have a 140-degree angle here. We're trying to find that side. We have side C. This side here has a magnitude of 200. So we've got a 200, a 150, we've got a 140-degree angle in between the two. And so we can go ahead and pop this into the law of cosines. Law of cosines says that c squared is equal to a squared plus b squared minus 2ab cosine of c, okay? And in this case, c squared is going to be equal to, we'll make this a, we'll make this b, the middle angle here is going to be c. So it'd be 150 squared plus 200 squared minus 2 times 150 times 200 times the cosine, our angle measure there with the 110 and the 30 added together, it ended up being 140 degrees, okay? So basically, you plug and chug in your calculator and you call it a day. C squared is going to be equal to, let's see, 150 squared plus 200 squared minus 2 times 150 times 200 times the cosine of 140. And that's going to be a huge number, 108,462.666. Take the square root of that, and we're going to get about, C is approximately 329.34 newtons, okay? Now notice something here. These two people are pulling in close to the same direction, okay? This person's kind of angled this way, but in general, they're close to the same direction. So notice, the sum of their two forces would be 350. That's not too far from 350. That would be if they were in exactly the same direction. But since they're close, we're going to get an answer that's not too far off from just the sum of the two values. Okay, so that answer should make sense. Okay, meanwhile, if they're playing tug of war and they're opposing each other, we would see a lot of canceling out of those forces in opposite directions. All right, the angle measure. Okay, the angle measure is going to be this 30 plus this angle right here. Okay, so if you remember from the, if you've seen the other video, we've got a 140-degree angle here. We want side C. Oh, actually, we know side C. Side C is 329.34. Okay, so we've got an angle and its opposite side. We'd like to know this angle here. I'm going to call this angle X, and we have its opposite side is 200. Okay, so we can do this as a law of cosines. Remember, if you have two pairs of angles and opposite sides paired, and only one of them is a variable, you should be able to use the law of cosines. So we have an angle and its opposite side. So according to the law of sines, 329.34 over the sine of 140 is going to be equal to this side length of 200 over the sine of its opposite angle, which I've labeled x. All right, and so we can cross multiply here. 200 times the sine of 140 is going to be equal to 329.34 times the sine of x. I'm going to divide both sides by 329.34. And again, make sure you're in degree mode. 200 sine of 140 divided by that 329 answer, which I'm going to use from previous. Okay, so we're going to get that sine of x is approximately 0.390. I'm going to take the inverse sine of that answer, and that tells me that we have about a 22.98 degree angle there. Okay, so the overall angle here would be about 52.98 degrees. So we could say it's going to be about 329.34 newtons at an angle measure. And by the way, we didn't talk like north, south, east, and west in this case. So I'm just saying if they're saying that's a 30-degree angle, we'll just say this whole thing is a 52.98 degree angle and be done with it. So we could think of like a 0 to 360 kind of turn here if you wanted to do it in that sense. Okay, so hopefully those examples make it a little bit easier. These are not real quick problems, but they do tend to get pretty predictable after you've done a few.